Hi and welcome to this Now Maths Revise Now video on factorising quadratic expressions where a is greater than 1. So what does it mean to factorise an algebraic expression? Well, it means that we need to put the algebra into brackets. In this video we're going to focus on expressions that can be factorised into double brackets. And in particular we're going to look at quadratics of the form that are on the screen now, where the number a is greater than 1. If you would like more help on factorising quadratics where a is 1, please check out our dedicated Revise Now video on this. In this particular video we're going to focus on a method known commonly as either the AC method or factorising by chunking. So looking at our first question, we're asked to factorise fully 6x squared plus 17x plus 12. To use the method of chunking or the AC method, the first thing that I'm going to do is I'm going to label the coefficient of x squared a, the coefficient of x b, and the constant c. We're then going to work out the value of AC. And in this case, a is 6 and c is 12, and we need to multiply them together to work out AC. And 6 multiplied by 12 is 72. We then need to find a pair of numbers which multiply to make 72 and add to make 17. So let's start listing some factor pairs of 72 first. So for 72 we could have 1 and 72. We could have 2 and 36. 3 and 24. 4 and 18. 5 is not a factor of 72, but we could have 6 and 12. 7 isn't a factor of 72, but we could have 8 and 9. And since we've already got 9, that's all of the factor pairs. We now need to work out which of these pairs has a sum of positive 17. Looking through our list, the only pair which have a sum of 17 or add to make 17 is 8 and 9. So we're going to use this pair. Now we're going to go back to the question and we're going to separate this 17x into 8x add 9x. So we can rewrite this as 6x squared add 8x add 9x, add 12. And this algebraic expression and the one we started with are equivalent to each other. All that's different is that we've separated the 17x into 8x add 9x. We're now going to try and factorise this in two separate halves. So we're going to factorise the 6x squared add 8x, and then we're going to factorise the 9x add 12. And we're going to use single brackets to do this. So looking at the first half of our quadratic, the highest common factor of 6x squared and 8x is 2x. So we're going to put 2x on the outside of our bracket. And then on the inside of our bracket, 6x squared divided by 2x is 3x. And 8x divided by 2x is 4. Now looking at the second half of our quadratic, 9x and 12 have a highest common factor of 3. So we put 3 on the outside of our bracket. And then 9x divided by 3 is 3x. And 12 divided by 3 is 4. So we have 3x plus 4 inside our bracket. Now what we've done is we've separated this quadratic into two terms. And each of these terms has a common factor. And the common factor is 3x plus 4. So we're going to pull out the factor of 3x plus 4. Now for this first term, if we divide this first term by 3x plus 4, we will be left with 2x. For the second term, if we divide this second term by 3x plus 4, we will be left with 3. So we have 2x plus 3. And hopefully you can see that the first bracket is made up out of the common factor in each term. And the second bracket is made up out of the 2x and the plus 3. If we wanted to check that this answer is correct, we could expand the double brackets out and check that we end up with the quadratic that we started with. Now, for our second question, we're going to factorise 4x squared plus 4x subtract 15. We're going to use the same method, but we're going to have to be a little more careful because we have a negative 15 in this one. So the first thing we're going to do is label the coefficient of x squared, a, the coefficient of x, b, and the constant c. We're then going to work out the value of AC. So in this case, our value of a is 4, and our value of c is negative 15. And to work out AC, we multiply together, and 4 multiplied by negative 15 is negative 60. We now need to find two numbers which have a product of negative 60, or multiply to make negative 60, and have a sum of positive 4, or add to make positive 4. So let's start listing some factors of negative 60. And this time, if we want the two numbers to multiply to give us a negative number, one of the numbers will have to be positive and the other will have to be negative. So let's list out some factor pairs. So we could have negative 1 and 60, or we could have negative 60 and 1. We could have negative 2 and 30, or negative 30 and 2. We could have negative 3 and 20, or negative 20 and 3. We could have negative 4 and 15, or negative 15 and 4. We could have negative 5 and 12, or negative 12 and 5. We could have negative 6 and 10, or negative 10 and 6. And they are all of the factor pairs that could multiply to give us negative 60. Now we need to find the pair which have a sum of positive 4. So looking at all of the numbers that we've just listed, the only two numbers which would add to give positive 4 are negative 6 and 10. So we're going to split this positive 4x term into subtract 6x plus 10x. So when we rewrite our quadratic, we write 4x squared, subtract 6x, add 10x, subtract 15. So we've broken up this term into the factor pair that we just found. And this quadratic is identical to the quadratic we started with. We now factorise this in two parts. So we're going to factorise the first half, and then we're going to factorise the second half. So looking at the first half of this quadratic, 4x squared and negative 6x have a highest common factor of 2x. So we're going to take a factor of 2x. And then 4x squared divided by 2x is 2x. And negative 6x divided by 2x is negative 3. Then looking at the second half, 10x and negative 15 have a highest common factor of 5. So we take a factor of 5 out, and 10x divided by 5 is 2x. Then negative 15 divided by 5 is negative 3. We now have an expression with two terms in it, and these terms have a common factor of 2x minus 3. So we bring out our common factor of 2x minus 3. And if we divide the first term by 2x minus 3, we get 2x. And if we divide the second term by 2x minus 3, we get positive 5. So we've now factorised our quadratic expression, and similar to last time, hopefully you can see that the first bracket is the common factor in each term, and the second bracket comes from the 2x plus 5. Now taking a look at a third example. This time we're going to factorise fully 4x squared, subtract 3x, subtract 10. We're going to use the exact same method to attempt this question, except again we're going to have to be a little more careful because we actually have two negative numbers this time. So the first thing we're going to do is label the coefficient of x squared a, the coefficient of x b, and the constant c. We then work out the value of AC, which in this case a is 4 and c is negative 10. So we do 4 multiplied by negative 10, which is negative 40. We now need to list out the numbers which have a product of negative 40. And if two numbers are going to multiply to give us negative answer, we need one of the numbers to be positive and the other to be negative. So starting off, we could have negative 1 and 40, or negative 40 and 1. We could have negative 2 and 20, or negative 20 and 2. We could have negative 4 and 10, or negative 10 and 4. We could have negative 5 and 8, or negative 8 and 5. And that's all of the different factor pairs which would multiply to give us negative 40. We now need to find the pair which will have a sum of negative 3, or add together to make negative 3. Looking at our list, the only pair that will have a sum of negative 3 is negative 8 and 5. We now go back to our question and we rewrite our quadratic, except we are going to split this negative 3x term into negative 8x plus 5x. So we write 4x squared, subtract 8x, add 5x, subtract 10. And this quadratic is identical to the one above. We've just split the negative 3x term up. We now factorise in two separate halves. So we factorise the 4x squared subtract 8x first, and then the 5x subtract 10 second. So looking at the first half of the quadratic, 4x squared and negative 8x have a highest common factor of 4x. So we bring that to the front of our bracket. And then 4x squared divided by 4x is x. And negative 8x divided by 4x is negative 2. Then looking at the second half of our quadratic, 5x and negative 10 have a highest common factor of 5. And 5x divided by 5 is x. And negative 10 divided by 5 is negative 2. Now we have an expression with two terms in it. We have a common factor of x minus 2. And for the first term, if we divide this first term by x minus 2, we have 4x. And the second term, if we divide this by x minus 2, we end up with 5. And again, if we want to just do a quick check, we can see that the first bracket is the common factor that we had above, and the second bracket comes from the 4x and the plus 5 above. And this is our fully factorised answer. Now for our final question in this video, we're going to factorise 15x squared, subtract 11x, add 2. So we're going to start this in the same way we did with the previous questions. The coefficient of x squared is a, the coefficient of x is b, and the constant is c. We then work out the value of AC, And in this case, A is 15 and C is positive 2, and 15 multiplied by 2 is 30. We now need two numbers which multiply to give us 30, and we're looking for the pair that have a sum or add to make negative 11. Because we're looking for two numbers which have a positive product and a negative sum, we're going to have two negative numbers in order to do this, because two negative numbers multiply to give us a positive answer. So starting off, we could have negative 1 and negative 30, because they multiply to make positive 30. We could have negative 2 and negative 15, negative 3 and negative 10, and negative 5 and negative 6. And that's all of the possible factor pairs that we could have. We now need to identify the pair which add to give us negative 11, and the pair which add to give us negative 11 will be negative 5 add negative 6. So we now go back to our original quadratic and we rewrite it, but we separate up this middle term into subtract 5x, subtract 6x. So we write 15x squared, subtract 5x, subtract 6x, add 2. And this quadratic expression and this quadratic expression are identical. We've just written it in a different way. We now factorise in 2 halves. So we factorise this part first and this part second. So looking at the first half, the highest common factor of 15x squared and negative 5x is 5x. So we put that on the outside of our bracket. And then 15x squared divided by 5x is 3x. And then negative 5x divided by 5x is negative 1. So that goes second. Now looking at the second half, we have negative 6x and 2. These two numbers have a highest common factor of 2. And given that this first term here is a negative 6x, we're actually going to take out a factor of negative 2. So if we take negative 2 to the outside, negative 6x divided by negative 2 is positive 3x. And then 2 divided by negative 2 is negative 1. Now we have an expression with two terms, and these two terms have a common factor of 3x subtract 1. So we write down 3x subtract 1. And if we divide the first term by 3x subtract 1, we get 5x. And if we divide the second term by 3x minus 1, we get negative 2. This is now fully factorised, and just so we can do our check again, 3x subtract 1 is the common factor, and we can also see that the second bracket comes from the 5x and the negative 2. Thank you for watching this Now Maths video. Please like and subscribe if you found this helpful, and we'll see you next time.